Hello everyone, it's Benny, and welcome back to the 3D game programming tutorial series. Last time, we continued our quest to implement a pure entity component system, still not to be confused with a system of entities and components, and the terminology is still terrible. But we made some good progress. We have pretty much all our core data structure in place, both for the ECS and for the components, which have a runtime dynamic type system, which is a little bit tricky in a language like C++. So with that in place, really the biggest thing we have left is we need to implement the public interface so that we can actually add things to our whole entity component system and it can do something remotely useful. So that's what we're going to be doing in this video. Let's dive into it. So to start with, we're going to create a new folder for all of our implementations. ECS.cpp. We're going to include ECS.hpp. And we're going to start by implementing the destructor. Why the destructor, you might ask? Well, this class is going to have to do some interesting memory management, both with the components and the entities. And by knowing what we have to do to clean everything up at the end, that'll give us a better feel for how to manage the memory properly and minimize the chance of memory leaks. That's the theory anyways. So to start with, we're going to have to go through our entire list of entities. And you could do components first, but I'm going to do entities. And what I'm going to do is I'm going to do something very difficult. I'm going to delete, get this, entities sub I. That's it. That's all there is to it. Very, very straightforward. And the reason is we will have to manually allocate a new pair of these for every single entity, which is a little unfortunate, but we could work around it if it really becomes an issue later on, so I am not overly concerned about it. We could always improve the memory management. Right now, this is the simplest thing that works and still has a reasonable chance of doing a good job. So that's why I'm doing it. And that's all we need. So, with that, all we have now is the incredible complexity of the components. Of course, in reality, I don't think our component is actually that bad. It's just the syntax might be a little bit weird because of the runtime dynamic type system. So, what I'm going to do is I'm going to copy the type of our components, which is a map of arrays to integers, and I want an iterator of that, called IT. That's going to start at the beginning of the components map. And while this is not the end, there we go, then we're just going to increment this iterator. And that is how we're going to go through the map. Now, if you aren't too familiar with iterators, in this case, the iterator is going to act like a pointer to a pair. So it'll be like a pair of a particular unit integer and its corresponding array. It'll just act like a pointer to that. So I could do something like, say, the size, and I'm call it type size. And here I can look up in base ECS component. And just to remind you of how we wrote that, our base ECS component has a method called getTypeSize that does exactly what we're after here. We can get type size, and we can use the first element of this iterator, which right here, that should be the type ID. And yeah, this should get us the size of the component with this particular type ID. And that's actually the first piece of information we're going to need to know to be able to delete these properly. The other piece of information you might actually be able to guess is the free function. We need to know how to free this particular type of component properly. I'll just call it freeFN, sure. It's as good of a convention as any. And once again, that's base ECS component, get type free function ID first. And again, we're accessing like this because it acts like a pair. So the type ID is the first element of the particular pair. There we go. So now we have the type and free function of one particular component. So what? How do we free the components? Well, I actually don't know if I said this or not. I may have completely skipped over this, but yeah, the array of unsigned integers, that's acting like just almost like arbitrary memory for our components. So this is like an opaque block of memory that we're storing our components in. It just happens to be typed as an array of unsigned integers because it has to be typed as something. And this has a nice property that's easy to resize that opaque block if needed. So what we're going to want to do is we're going to want to iterate through this block of memory. I equals 0, I is less than, and we'll use it second, which is accessing the array, dot size, so the size of this array. And we're going to increment by type size, because if all the components are the same type, and every component of this type is this particular size, this should go through every single component in this block one at a time. Hopefully that makes sense. Because they're all that size. But anyways. And once we've done all that, once we are there, then it's actually really straightforward. All we have to do is call the free function on every single one of those components. So the free function, if you look over here, takes in a base ECS component reference. So I'm going to need to go under it, arrow second, that gives us the array. The index is going to be I. I is the correct index because we're incrementing by type size. And all we need is the address of this. And that should give us a reference to the base ECS component. This is a base ECS component because all components inherit from base ECS components. So this is safe. In fact, I'll just go ahead and explicitly cast it to a base ECS component pointer, just to be clear. So this will free every single component in the array. And we'll do this for every single one of these arrays. So that will get rid of all the components. That's how we delete it. Hopefully that makes sense. I know it's a little bit weird because of our dynamic type shenanigans. But hopefully that makes sense. So, now that we have our destructor, what about the rest of it? Well, we already have it sort of divided into these sections of the entity methods, the component methods, and the system methods. So I'm just going to take it one section at a time. Let's take it from the top with the entity in the make entity method. How do we create a new entity for our entity component system? Well, if I close out of ECS component for a moment, we already have a type set up for our entity. It's this pair of nonsense. Not even going to bother pronouncing it because it's just really wordy, but that's okay. So this will be our new entity. We're going to have to somehow or another create something of this type. And we're going to do it the most straightforward way possible. We're going to use the new keyword with the type, delete the pointer, change it to parentheses so it refers to the default constructor, and we're done. That's it. Of course, that's not really it, because we ultimately need an entity handle, which I'll just call handle. And as you sort of saw a bit earlier, did I show you that at some point yet? I don't know if I did or not, but yeah, entity handle is just going to be this pointer, except opaque, so other types don't need to know or care that we're using this insane type. Only we need to care about the insanity. Nothing else in our entire program needs to care about this. So we have that. Now, the uint32, that is going to be the index of the entities array. So I'm going to say new entity arrow first. That is going to equal entities.size, which is good. That tells us essentially the new index is going to be added to once we do entities.pushback new entity. And there we go. At that point, yeah, we'll need to populate the array with the components, but I think that's pretty much all the fancy shenanigans we need to do. At that point, I think we can just return the handle. And for the rest of it, we can just worry about the components. So I'm going to start with an iterator. It's going to go through I equals 0, I is less than, num components. And we're just going to go through every single one of the components and add it to this entities array. And first, we're going to have to check if component ID is actually valid. Because it is possible we pass a component ID that doesn't actually exist. That would be very, very bad. We want to throw some kind of error if that happens. So we'll do that in a second. For now, let's pretend everything works out, and let's handle just the basic case. Everything works out, it is a real component, there's no errors happening. What's the correct way to do it? Well, what we'll need is we'll need to be able to create it, and I should want to create the window here. Yes. So we will need the create function for this component, because we're going to be creating it in our component memory. Yeah, we're being passed references to it, but ultimately the ECS component, the ECS system, the ECS class, there we go, that is going to be handling all the memory of the components it actually uses. And the reason for that really is straightforward. The ECS system is what knows when components are created or deleted, so it makes sense that it should be the one in charge of the memory. So we need to copy it and create it with the ECS create component function. And that means we need to get the type create function. So it's called createFN using my convention, base ECS component, get type create function, make sure you have both colons, not semicolons. And the type create function will be for component IDs sub I, for current component ID. So cool, now we know how to create a component of this particular type. Now what? Well, now we need to actually call it. So we're going to call the create function. The memory is going to be new entity. It's going to be the second. Yeah, that passes by reference, so that checks out. We need the entity itself, that'll just be the handle. And last, but certainly not least, we need the components. So component sub I, and we need the address of that. So this creates a new entity in our component memory, and this will return to us the index of that component. So here's where we're going to be setting up the new entity's parameters. So basically, we're going to say new entity arrow right. I just made an error that could have been very bad. We're not creating in the entity's memory, we're creating in this components array. Yeah, that's a little bit tricky, so don't make that mistake. Don't do what I just did. We want components, and we want components sub the component IDs sub I. So we're going to look at the current component ID, whatever our array of component memory for that particular component type is, that is where we're going to be creating this component. And then in new entity arrow second, we're going to want to push back, and yeah, we're just going to create a straight up STD pair. We're not going to do anything too fancy, just create the pair. Well, all right, I'll create it separately because the syntax is a little cleaner. I'll just call it new pair. We're ultimately going to push back the new pair, but this lets it be a little bit nicer because now we can say, excuse me, we can say new pair dot first equals 1 second, and new pair dot second equals this. There, I wanted to paste that before I forgot. So our second is going to be the index of this new component, and this is just going to be the component ID. So there we go. We've created a new pair. We're handling the creation of new components. And yeah, we can create entities. We can pass a list of components. It'll create for every single component, and we should be good to go. The only thing left, though, is what if the component ID is invalid? And we need a slight change to ECS component.hpp for this to work. Not anything too major. We just need to know how can we know if component type exists. So boolean is type valid uint32 ID. And we're going to be taking advantage of the count function. So if the count, so this tells us how many elements are at the key, and oh right, this is an array. So never mind, I'm not doing it with a map, I'm silly. So because we're doing it with an array, it's actually much simpler. We're going to return if ID is less than 0, which shouldn't happen because it's a uint32. That should be impossible, but whatever. Or ITD is greater than or equal to component types dot size. But yeah, at least this way, I guess if I change the type, I'll probably have to change everything else anyway, so okay, fine. I'll get rid of it. Though actually, yeah, that's fine, that's fine. So now we have a way of checking if a type is valid. Oh, yeah, we're just gonna do that basic check. So if, again, we already have the components ID. So base ECS sorry. Let's say, is type valid? I have it returning backwards. If it's less than that, it should return true because it's valid. If it's greater than or equal to components.types.size, it should return false because it's invalid. So is type valid, component ID, sub I. Great. If the type is not valid, this is when things will get weird. Obviously, we need to delete the new entity because that's just wrong. You know, we don't want to have dangling memory. We're also going to return the null entity handle, which we defined right here. And we probably also want to report some sort of error. So I'll say debug log. Actually, I don't think I've used this in the series yet. So in core/common.hpp, something I have are these nice macros to easily log errors, warnings, temporary print line debugging, just stuff like that. Very nice and easy like that. And they could easily be disabled if necessary in certain builds. So that's nice. So we can pass in the category, which could be, here I have renderer IO, or we could pass in a custom string, which we'll probably do in this case. And the level, which tells us if it's error, warning, or something else, we're going to be error. And then lastly, the message and any arguments, because it works like a printf statement. So, oh yeah, that's the other advantage of this. It doesn't necessarily have to print to the console. We can easily redirect this to print to a file, in the case of logging, or something else. So that's why I set that up like that. But yeah, we're going to use debug log. We are going to, like I said, for the category, we'll just say ECS because it doesn't really fit anything we've defined so far, nor do I think there's really a good generic category for this, at least not right now. We're going to be error, because this is wrong. We should not be adding invalid types ever. And what should the message be? Sure. %u, I'll put it in low quote marks, is not a valid component type. And our var args will be component IDs sub I. There we go. That should be everything. This should be all we need to do to create an entity. So, of course, we had the compilation test, and there's a couple things we missed. First off, actually a holdover from last video, interestingly enough, handle to raw type, I forgot the return keyword. Kind of important. Beyond that, I'm going to do some slight shuffling. Don't mind me. Because our base component pointer is called components. Our member is also called components. That's a little confusing, so just to clear that up, I'm going to change this to entity components. And that should make things a little bit nicer. In fact, I think that's the only place I reference. Sorry. This is the only place I reference it. Yeah, because this is where I look at entity component sub I. I pass it as it's already a pointer. I don't know why I'm taking the address of it. I mean, I'm not crazy. It is already a pointer, right? Yeah, we're taking in pointers. This, I am crazy because dereferencing it gets me the raw object, so I need the address of the index to get the pointer to it. Okay, never mind. Never mind. And that should be all we need to do to create the entity. So, next up, we can create entities. How about removing them? Sure, they get deleted when the program's over, but ideally there's some way to remove entities while the game is running. I don't want to be able to shoot a bullet and the bullet stays around forever, for eternity. That bullet's just always flying around. Even if it hits something, it's still there, forever lost in the void of games. No. That would be Again, that'd be kind of interesting, though, if you had like a forever bullet that literally stays with you for the rest of the game. That'd be an interesting concept. You could maybe build something out of that in the game, but yeah, we're not doing that right now. We're going to create a way that you don't have to have forever bullets. You can have normal bullets, or just remove anything. Anything you care to remove. So, the big thing we're going to be doing here is we're going to be taking advantage of our handle. So I'm going to say handle to entity, handle, because we need this array of pairs. So this is going to be called entity. Sure. And what we're going to do is, the first thing we need to do is we need to make sure all the components are gone. So I'm going to go through the entire list of entities, entity.size, and what I'm going to do is I'm going to remove component, and I'm going to actually not use the one we have here, because this one requires us to know the type of component beforehand. We don't know the type of component here, so we're going to have a remove component internal. This is going to be an internal way of doing component removal, and this takes in straight up the entity ID and its index. So what I'm going to do in remove component internal, or excuse me, what I'm going to do here is I'm going to take entity sub I first and entity I second. Those are the parameters. The only thing is now we need to define it. So it's going to be a private method. It's going to be void remove component internal. Well, should it be void? Yeah, I'll make it void. I can make it a Boolean later if I need to. So it takes in the component ID and index. Yeah, that should be all we need. So, once all the components are gone, then we can safely remove the entity from the list, because we don't have any dangling components left in here. It's not doing anything with the system, so everything in here checks out. All that's left is we need to remove it from the entities list. Now, we could do it the naive way of just removing it and adjusting the array, or we can be a little bit clever about this. Remember how I set this up so that we have a way to get the handle to entity index? Yeah, this is why, viewers. So what I'm going to do is I'm going to have this index. I'm going to call it, desk index, which, it's the current index, wherever this entity is in our list of entities. I'm also, predictably enough, going to have a source index. You might recognize this paradigm from C programming, because this is going to be entities, and it's going to be sub-entities dot size -1. So this should give us the last entity in our entities list. You might see where I'm going with this. So what I'm going to do is I'm going to say entities sub-dest index, guess what, equals entities sub-source index. So I'm moving the last entity in the list to where the entity we're deleting is. And I can do that because we don't care about the order of this list. Logically, the order of this array is completely irrelevant. All that matters, logically speaking, is that this contains every entity so that at the end, we can delete all the entities and there's no lost memory. So, this gives us a really efficient way to remove entities. Now we've bypassed the needing to shift elements in the array. We've just replaced the deleted entity with the one that was at the end of the array, and now we can just say entities.popback to remove the last element at no cost. So, assuming there's a small number of components, this should remove an entity in constant time. And really, there will be a small number of components, because you're not going to have hundreds of thousands of different components on the same entity. You're not even going to have hundreds of components on the same entity. There's actually a study out there that shows you the typical AAA game has roughly 150 different types of components in the entire game. That's it. So you couldn't have thousands and thousands of different components on the same entity, even if you wanted to, because there just isn't enough component types for that to be possible. So, whole point of that being, this will be small in practice, so in effect, we'll be able to remove entities really quickly. And we can also add entities really quickly because the only loop in here is again over components, which again is going to be small in practice. So as long as this new doesn't take a ludicrous amount of time, which it shouldn't, we can create and remove entities really darn fast. The only thing though is there's a subtle bug here right now. We're not quite done with the remove entity method yet. Do you see the issue? You might see the issue because there's a new right here and there's no free. Where's the free of the remove entity? If I'm removing it from the list of entities that are freed, it's not deleted here, so we need to delete it manually. That's really simple though. All we have to do is say delete entities. Yeah, I'll just copy it. Entities subdest index. There we go. So this deletes the entity we're removing and is replaced by the one at the end. All is well in the world. So, as always, we have a few typos. Notably, source index, don't need to dereference the array to do that, so that should just be entities.size -1. Also, up here, we don't need to address these like these are pointers because they're not. We're just straight up getting the pair. And lastly but not least, if you try compiling right now, we haven't written remove component internal yet, so that'll give us a linker error. So we can just temporarily give this an empty declaration so that we can compile and run and all is well in the world. It won't work correctly, but it lets us compile and run. But, this is all begging the question. We have entities done. What about the components? It seems like we really need components in there for any of this to mean anything. How do we do that? Find out next time! I hope you enjoyed, I hope you learned, and I will see you in the next video. As always, if you'd like to talk more with me or other like-minded people, please join the Benny Discord. It's a fantastic place, and you are always welcome. If you want to support these videos, or you'd just like to find out right now, consider becoming a patron on Patreon, because you can get early access to videos, special roles on Discord, special bonus video materials. You can get even possibly a special thanks in these videos. So thank you very much to all my patrons for making these videos possible, and a very, very special thank you to the people listed in the video description. You all are awesome. With that, I will see you in the next video.